Okay, welcome to this video, and what we're going to take a look here at is solving a system of equations using matrix inverses. Okay, and we see this question here. It says write a matrix equation for the following linear system, then solve a linear system using the inverse matrix. Write the inverse in the multiplication. For those of you who take my class, it's very important that you follow the writing style shown in this video. It's consistent with the one I do in class, and it is required for full credit on a test. So let's start with making a matrix equation here, and we should see that what's going to happen with that is I'm going to make a coefficient matrix to start, which is going to be with the coefficients that appear in the left side of the equation. And I will do those in red. Okay? So I will make a 3 by 3 equation, which makes matrix, which makes sense because it's 3 equations and 3 variables. So I'll start with 4, -3, and 1. Again, the fact that there's one z there needs to be noted. Its coefficient is 1. Followed by 1, 3, -1. And then the bottom equation, you notice it only has 2 variables in it. Well, we have to account for the third by saying that there are 0 y's. So I'll start with -1 for the coefficient of x, fill in my 0 for the y, and then place a 2 here for the coefficient of z. Okay? Another thing that needs to be noted here is that when you do this, they have to be in order. The whole first column has to be the same variable, and I've chosen x. The second column has to be the coefficients of the same variable, which is y. And then the third column needs to be the coefficients of the third variable, which in this case is z. So again, this is called the coefficient matrix. You don't have to write that part, but I'm just noting it for vocabulary sense. And then I'm going to put the variable matrix here in purple, which is very simple. It's just x, y, and z. This is the variable matrix. Then we're going to say that that is equal to the constant matrix, and the constants are just what each equation is equal to. And again, they're called constants because they don't have any variables involved with them. So from here, I'm going to write a 3 by 1 matrix of 27, -2, -9. Okay? Decently straightforward here to start. This is this part of the problem where we have written a matrix equation. Okay? Now, before I go forward, just a quick note on why this works, because if you multiplied these two equations out by using matrix multiplication, you would in fact get that group of expressions back. Okay? This is why it works. It's not some magical leap from here to here. They are in fact equal by the laws of matrix multiplication. Okay, so the one thing we notice here is we have a decently straightforward structure of matrix A, I'll call it, times x equals b. And we'll try and show this just by drawing these lines of what represents what. Well, from there, we've seen that if we can just find a way to multiply by the inverse, and I'll put that in orange, on both sides, it would allow for us to be able to say that the inverses will cancel each other, and then the equation is hence solved. So the direction I take this should be decently easy to see if you comprehend that inverses create the identity when you operate them. Creating the identity is what happened right here. Okay? The result of multiplying two inverses creates the identity, and the identity is simply 1, 0, 0, 1, which doesn't have to be written. It's kind of the equivalent of just the number 1 in the real number system. So what I need to do here is make sure that I can compute the inverse of matrix A. And again, matrix A is just the coefficient matrix. So I will need to go to my calculator. Okay? So on my calculator, I will hit second matrix. I'll go to edit and choose A. I'll see that it's a 3 by 3. And then I will enter the entries accordingly by saying 4, enter, -3, enter, 1, enter, Okay, just a little video magic there to get it all entered quickly where I paused it. And then I'm going to need to enter the constant matrix in matrix B, I'll say. So I'll go to second matrix, go to edit, choose B, and that is a 3 by 1. And I won't pause the video because it's small matrix, 27, -2, -9. Okay? And then I'll just go to second quit. Well, for the sake of my writing, I need to see what A inverse is. So let me compute that on my calculator here. Okay? And I will take second matrix, hit enter to bring A into the home window, type x to the -1, and hit enter. Now that is the inverse of A, which the whole problem hinges on. Even though I'm doing it on my calculator, the theory here is really important. I'm going to hit math enter enter to make it fractions so it's easier for me to read. And then again, what I'm going to do is commit to writing this well. So I'm going to write in orange A inverse. Okay, and I'll try and match the colors coincidentally for what I have up here. Okay, so I've got A inverse is going to be 1/5, 1/5, 0, -1/30, 3/10, 1/6, 1/10, 1/10, 1/2. Okay? And then I'm going to multiply that by A, okay, which I'll recolor code. I'm sorry that it's orange against red. You should be able to see that still. Okay, and I'm going to bring that down and say 4, -3, 1, 1, 3, -1, -1, 0, 2. Okay, and then I'm going to do my X matrix, which is just the variables, X, Y, and Z. Now the moment of truth, if you really understand matrix multiplication. I have to get this order right on the right side because if I just did B times A inverse, the size rule would be broken and it wouldn't even work. So what am I about to do? I'm about to make sure that I write my A inverse, okay? Which again is 1/5, 1/5, 0, -1/30, 3/10, 1/6, 1/10, 1/10, 1/2. And I will be multiplying that by matrix B, which I'll just bring down from the equation, 27, -2, -9. Now from here, I realize that inverses will cancel each other. And just in that magic swipe, I've gotten x, y, z by itself. Now just for a moment, I'm going to write up here in blue. Don't forget, when I crossed out here, I created 1, 0, 0, 0, 1, 0, 0, 0, 1, which is in fact the result of that multiplication. So it's kind of like to write that would be sort of writing the 1 when you solve a simple equation, which we allow you guys to cross it out, know that it's kind of canceled, and you don't need to write it. So this is going to give me my answer of x, y, z is equal to this computation, which is A inverse times B, just by the simple theory we stated earlier. So the only thing I need to do now is go on my calculator and compute that. So I will do second matrix A inverse times second matrix B by selecting number 2. And just in the way that I have written it on my paper, it appears on my calculator, A inverse B is in fact 5, -3, -2. So I'll write that in purple to reiterate the fact that these two matrices are really the same. So from here, you see that x equals 5, y equals -3, and z equals 2. Now, don't lose sight of what this means. The only thing you've done is solved, which is found the missing numbers that make all of your original equations true. So if you wanted to check, you could actually put those in on your calculator and type the original equations and see if you get true statements. So the writing here is really important, okay? There's a lot of writing compared to the buttons that you use, which do a lot of magic. but we are noting in the writing that we have shown that you've multiplied by the inverse on both sides in the correct order to cancel a matrix, to get a matrix of variables by itself, per se, which means to solve for those variables. So enjoy. Feel free to watch it again, and I hope this was a help. Okay, major questions? There.